morning to all. Myself Mohammad Khadir, working as assistant professor in ECE department. Today we are going to see my course as integrated circuits and applications. So today we are going to see the topic is introduction of integrated circuits. So what is meant by integrated circuit? Earlier in our history, if you see the history of integrated circuits, the beginning of after Second World War or First World War, where the equipment which we have used for the reliability, maintainability, and in that real-time scenario, where we have used the different type of devices, so which can be in a large size. For an example, if you see a computer also after Second World War, the big size, it consists the room size, where that if you want to perform a small bit of operation also, we required to use a big size of devices. So then after that, 1948, the way the transistor, the semiconductor which came into the market, which we have designed by the scientists, 3 American scientists which have worked on to the designing of integrated circuits, are transistors, which by using the semiconductor electronic components, where they have after that 1958, the big small size of integrated circuit which is came into the market, which makes a big change of your entire device's size, which can be reduced at room size of computer to be a handset of computer. Nowadays we are seeing we can be used a small size of a device which can be perform a huge task, huge operation, huge bit of operations we can be performed easily within the instant of time, fraction of seconds or time. So like what is happened, how they are changed this one means, let's first begins with that what is mean by a integrated circuit. Means the electronic components of any semiconductor electronic components, not only electronic, any semiconductor electronic components can be connected as a circuit in a single block or single chip, which is called as a integrated circuit. Integrating a components. What are the components means? Any electronic semiconductor components which are active or passive. What are the active components means? Transistors, diodes, xenodiodes, FETs, etc. Which we have known that in a earlier semester subject, which we have seen that the components, and we have used in our laboratories also. And coming to the passive components are very resistors, inductors, or capacitors, which are going to be connected as a circuit into a single block. We are making a single block to perform a single operation. Nothing but if you want to perform a bit of operation, convert into analog to digital, or if you want to make an amplification process, if you want to increase the audio signal, voice signal, or etc. Anything can be in the communication sector, in image or image processing, signal processing, video processing, or anywhere, whatever the operation you want to perform in form of a storage or in form of a processing, which can be performed by using a huge components we are required to perform. That entire circuit we are making into a single block, which can be replaced that complex of your circuit. It is a big advantage, big change came into the market after Second World War. So integrated circuit, it's a huge difference we have taken into the place to which replaced by the complex of circuit, and by that we have reduced our devices circuit, which can be performed fastly with high reliability and etc. So what is an integrated circuit means? If electronic components are interconnected in a single chip of semiconductor material, that semiconductor material can be active or passive components, which is called as a integrated circuit. If you use normal any circuit or resistors, capacitors, or transistors, any can be, if you are going to be connected as any circuit, we are connecting this circuit and we are placing into a single block. We are making into a single chip, which is called as a integrated circuit, where we will apply input signal and we will observe that output signal by using the output devices. Like we are integrating our circuit. And if you've seen that, another definitions of any integrated circuit or integrated chip means, an integrated circuit or an IC, it's a small chip. It's a small chip of a semiconductor material, which an electronic circuit, entire circuit itself, we are going to be dump into that single chip, which is called as a integrated circuit. And it is very small when compared. It is very small when compared to earlier existed circuit. Earlier, when we have designed the computers, we required some high level devices which we cannot be carried out also. By that the devices can be perform only small amount of operations. If you want to increase that operation size also, we need increase the devices size also. By that the complexity is increased. When this semiconductor came into that market, it is going to be replaced that entire devices, machineries and etc. all the things, other materials which are replaced by using our electronic components, which can be dumped into a single chip. So it is very small and it is very independent also. To make any circuit, to design any circuit can be performed easily. And what are the functions, how it is going to be performed means, the integrated circuits can be performed as an amplifier or oscillator or processor or next when we can add as a processor, controller. There are number of operations can be performed. Different type of operations can be performed using this. The operations can be anything, either arithmetical, logical, controller or storage or a conversion. Anything can be performed by using this integrated circuit irrespective of circuit. And by these ICs we can be reduce our complexity and we can increase the performance by reducing the size of this huge devices using this IC. And what are the advantages of integrated circuits? The advantages of integrated circuit is it's very small size. We are going to reduce our entire complex circuit. We are reducing the more number of components, more number of electronic and active and passive components. If you observe any oscillator circuit, if you observe any amplifier circuit, if you observe any modulation communication system circuit, where that number of components internally, very one number of components will be available in terms of active or passive, like resistor, transistors, etc. We are going to be connected together and making into a single block, single chip circuit, and we are going to give just input signal, and by applying some voltage we can observe our output signal easily within the fraction of time. So by reducing this size using these ICs, we can be performed fastly. The next advantage, big advantage of IC is your fastness, speed. We are totally very much speed we are going to be increased. That is one of the advantage. Next one is low cost. When you are going to use the resistors or capacitors, it's very small amount of cost we can be used to design a number of ICs. Either active and passive, all the components are very low cost, which can be used to design this huge difference of integrated circuits. The more number of integrated circuits can be designed by using this very low cost components, and which can be give more reliable also, more reliable. And next one, very less weight. Already we know that semiconductor materials are very less weight components which can be perform more huge operations. So it is one of the advantage where we can see use this components, very less weight components can be used to design these integrated circuits. And low supply voltage, where these integrated circuits are required very low voltage required, which can be from plus 5 volts to up to plus 12 volts or 15 volts, can be sufficient to perform any circuit. So very less power is required, very less supply is required. And moreover, when any integrated circuits will be functioned by using the three basic parameters, which are time, and another one is area, and another one is your power consumption. So in these three parameters are very effective one to design any circuit in the integrators by using integrated circuits. This integrated circuit has to satisfy this operation by using these three parameters. When time is going to be reduced, how? Means we are going to reduce the complexity circuit. The time will be adjusted by using the circuit complexity. And next one, area will be also reduced when you are going to be repulse that, when you are going to be remove that more number of components can be connected together, and then ICs will be replaced that more number of complex circuits or components. and by that the required power also will be required less power. So due to this, these three parameters are will be satisfied to any circuit when you are designed by using these ICs. So by that, these three are basic parameters when you are going to be design any circuit which can be satisfy these three parameters, then only we can able to implement in the next levels. And low power consumption, it already requires very less power. Electronics are which will be applicable unto the between the 5 to 12 or 15 volts, and high reliable because we are reducing the components by replacing that integrated circuits. Then the connections in between the medium in between the components or integrated circuit will be less reduced. By that reliability will be increased, and by that speed also will be the fastness between that pin to pin, component to component, circuit to circuit, IC to IC will be performed very highly, speedily, and it requires very small amount of time to execute that any operation. So this is the one of the advantage. It's a big advantage in integrated circuits. And cost reduction due to that batch processing. Here we are reducing the components, or we are replacing that circuits by using this integrated circuits. Then the size of that circuit will be, the device will be reduced, and operation will be performed very fastly. And these are all the things, and whatever that cost we are going to be used by using these components, it will be very less. So that cost of reduction will be that takes place. So these are the very advantage: less cost, small size, low power consumption. These are the advantages, and speed, area will be reduced. These are the different advantages of integrated circuits. And next one is classifications of integrated circuits. So how we are going to be classified this integrated circuit means they're based on this the circuit, based on the wide range of applications. Anything can be in electronics, in the real-time application like for signal processing, image processing, or communication sector, or in satellites, in defense sector, wherever we are going to be used our integrated circuit. Everywhere this integrated circuit are replaced nowadays. The mobiles are also one of the application, and the systems and handsets, the digital electronics or electronic devices which we are going to be used in our real-time environment for make an automation or in make reduce the manpower. We are going to use these ICs. So it will be classified, depends on their classification into two types. One is digital integrated circuit, next one is linear integrated circuit or analog integrated circuit. Digital integrated circuits will be works for digital applications where your performance in between the bits operation or digital operations. Like for an example, systems, your laptop or desktops or your mobiles, everything will be under consist of digital ICs in processor, etc. And the linear ICs will be applicable in a communication sector where you are going for see that modulation, demodulation, communication system, transmitting, receiving, everywhere we are going to use this linear for especially for oscillation. It's an oscillator purpose or amplification process, modulation process. We are going to be use this linear ICs applications as a depends on their required applications in different environments. And based on this, another the technology level, based on this IC fabrication technology, IC design technology, we are going to be used two types of ICs are classified. One is monolithic, another one is hybrid technology. Monolithic, basically regular interval of time, we are going to be use monolithic technology based ICs only. A hybrid, it's a combination. Another other classifications are based on the classifications of ICs are based on mode of operation, fabrication based, and complexity based. How these ICs will be classified based on this operation means if you are performing a digital environment, then it is classified into a digital ICs. And when you are going to perform an analog operations or linear operation, then it is classified as linear ICs or analog ICs. And the fabrication based, we can say that monolithic ICs and technology based ICs, and another one is hybrid based technology based ICs are classified. complexity based, there are different type of ICs are designed by using this complexity based office, which we have seen in the next. So mode of operation based, here we have seen that if you are going to be performing a digital operation, then it is a digital IC classification, and when you are going to be performing linear operations or analog operations, like for an example amplifiers or oscillations or modulation, demodulation, etc., there we are going to be use this analog ICs or linear ICs. And based on the mode of operation, if you are going to be when you are going to be classified into a digital IC, where we are going to be use digital ICs, we have seen that we know very well, if you have observed any digital systems or digital computers or mobiles, etc., processor, etc., internally it is going to be perform a bit to bit operation, bitwise operations we are going to be perform. Such ICs which are going to be perform bitwise operation, it is called as a digital ICs. Best examples are available in microprocessor, controllers, systems, registers, etc., where we are performing bitwise operation, means logic 0 and logic 1, zeros and ones are operations. Next one, analog ICs, where these analog ICs are used in a discrete networks, like for communication sector or in amplification process, transmitting, receiving, oscillations, etc. Performance of operations are performed by using that inputs are a signal. Input is a signal, either AC signal or pulse signal. It is going to be used to perform such operation in the communication system or etc. there, and the values will be stored for these analog ICs in form of voltage or current. In form of voltage or current. So in digital ICs, the output will be stored in form of a discrete numbers, which are zeros or ones in digital ICs. But in your analog, the output will be stored in voltage or current. The examples of these analog ICs are voltage comparators, regulator, operational amplifiers, and IC555 timers, etc. And based on the fabrication process, monolithic is one of the basic real regular interval of time we are going to be used the fabrication based IC, and thick and thin film IC in very few places we are going to be use. This is another type of fabrication IC. Fabrication material we are going to use different types, and hybrid IC, the combination of the above tools will be used to design this. If you see the classification of that one, it is monolithic, another one is hybrid based, and the third one is your thick and thin film. Is only one type of fabrication based ICs, where we are going to be used diode, transistors, and discrete components we are going to be used to design thin and thin film ICs. In monolithic ICs, we are going to be use active and passive components, nothing but resistors, transistors, and diodes, capacitors, etc. We are going to be make a single circuit and we are dumped into a single chip. That's why this is a more regular interval of time we are going to be used for design of IC. This type of monolithic ICs used for a different application, especially in for low power applications. Low power analysis can be high in this monolithic ICs. And the third one, hybrid, the combination of above two monolithic and thin film integrated via circuits to design this type of ICs. It will be used in only high power applications, high power analysis level. So very less places we are going to be used this type of hybrid based ICs. So monolithic circuits can be used to design these transistors. We are going to be used, one is bipolar, another one is unipolar transistors we are going to be. In this unipolar we are going to use MOSFET, JFET, and in bipolar we are going to be isolation electric material, which are dielectric material and PN junction diodes. We are going to be used to design this type of monolithic circuits, which can be performed or dumped into a related circuits can be dumped into a single chip, which is a monolithic circuit ICs. And in the hybrid base, it will be a combination of monolithic circuit and your thin and thin film based ICs can be combined together to design these hybrid circuits. And next one is the circuit complexity and chip sizes. The how this change is occur in the history of that integrated circuits can be seen here. The day to day, the complexity is going to be reduced. When you, if you have seen in the time of 19th century, where your every device which is going to be performed in a real time operation in for a different type of applications, we have used a big size of ICs. But nowadays, we are totally that in a big size of devices is reduced to a handset, small size. We are going to be carried that huge different IC in a handset to perform a huge application operation. Huge task can be. We can store a huge data in a single bit, single minute, fraction of seconds. We are going to be store the data. Within the fraction of seconds, we are going to be transmitting our data. Within the fraction of seconds, we are going to be perform a operation to convert from one form to another form, changing data, modulated, demodulated, or communication, transmitting, receiving, or performing conversion, storage. Is like any operation, analog and digital operation can be performed within the fraction of seconds by this changing of complexity of your circuits. So by using this IC, this is the big advantage to reduce the complexity of your circuits. So if you observe that in the earlier 1950s, the electronic device technology has dominated, which can be replaced your vacuum tubes. Earlier, the vacuum tube size is very high. By using this, we have designed a computer which can be performed very 4 to 8 bit of operation. That size of device will be that equivalent to a room size. But nowadays, we are going to perform a more than 1 TB of data can be performed within the fraction of second operations. We are going to be performed by using the small handset of device. That is the revolution has taken place from 19th century to 21st century. Nowadays, when electronics came into the market after 1947, after independence, the transistor is change a innovation. Invention of the transistor is change the revolution of the entire electronic system. So, when invention of this transistor is done by this in 19th century, the three scientists, American scientists who are William Shockley and Bradian and John Burden. Of these three scientists have developed our integrated circuit also after 1958. So coming to that complexity, if you have discussed the day-to-day, how it is the change. Directly we have not changed that the complexity of integrated circuits or the size of the devices from room size to a handset size, the palm size. The palm size of devices we have came into the market to do the more number of operations easily. So for if you have seen, if you have revised that history of this one, the complexity reduction will be in 1947, the transistor came into the market, germanium material we have used, which can be silicon and germanium, which can be started of this electronic system by using this transistor which can be used for design of integrated circuits first in the 1947. But big changes came into the market is in 1958 after the three American people have designed our integrated circuit exclusively by using this small number of transistors which consist from 50s to hundreds of transistors to perform any analog and digital operation. After that 1958 the silicon planar technology came into the market. And then after that first time, the small scale integration which have introduced, developed in 1960 to 1965, where the size is integrated that more number of components like hundreds to thousands of components are hundreds of components we are going to be interconnected to design a circuit in a single block, which is a small scale integration circuit. In the 1960s to 1965. Then after 1965, the using of components has increased hundreds to thousands of components we are integrated into a single chip, which is a medium scale integration. where it can be performed a high level application operation, which can be like a conversion or a amplification process or bit of storage devices, etc. And then a large scale integration which can be takes place the sometime the 1970 to 80. At the end of 1980s, it successfully is run with thousands of transistors, to 10,000s of transistors. Components are integrated into a single chip, which can be perform a huge applications, real time applications in in electronic system, for a electronic and communication system. And after that, we know very well the very large scale integration, which in 19th century and 20th century, in the beginning of 20th century, it successfully is run with more lakhs of transistors, and a huge change, the entire system change, or communication system or your storage device system, for example computer, laptops, handset, the devices is reached to handsets by using this very large scale integration only. The total everything, every devices is totally reduced into a single handset chip by using this technology, which is a very large scale integration, where the number lakhs of transistors are dumped into a single chip to perform a huge data operations. And next one is ultra large scale, is presently is running with this ultra large scale integration, ULSI. After 20th century, it's successfully running with millions of transistors, components are dumped into a circuit to make. And this VLSI and ULSI has done with a huge change, which can be work with low power consumption, with a high speed of data, and huge data can be stored, is area also reduced. Whatever that IC parameters are totally will be satisfied to develop a huge change into a real-time communication system or electronic communication system with variations which we have seen in our 20th century, how the change is occur from past decade to the present decade, how it is that IC is successfully run with using this VLSI and ULSI technology only. That totally everything is totally is going to be reduced into a small amount of size. Okay. And next one is presently running with the research is going on is GSI, giant scale integration circuits. This technology is going to be working under process of coming present running decades generation. And the types, how these ICs will be looks. What are the types? How they are going to be designed? What means, if you observe in your electronic system, any devices, if you assembled while assemble any electronic devices, like for motherboard of CPU or in laptop internal board, which we are going to be connected, well, we will see this type of ICs. These type of ICs we are going to be used to place like as a RAM or processor or any other etc. digital circuits. We are going to be use these ICs to place there. We can be view this type of things. And this is a metal cap based, the cap based, metal based. In our laboratories, we can able to see this type of ICs where we can be perform our analog and digital operations. And in our laboratories, this type also dual line. Both the side pins will be available. Dual means two sides. Line, two sides of line will be, the pins will be available. Irrespective of each pin will be consist their operation to perform. According to that, we are going to be use the pins to perform our required operation. As similarly, the next one is quad plat operation. We are going to be used one type of IC, this one. And next, the integrated circuit design. How they are going to be designed, what are the types are there, how it is classified means, the certain techniques are going to be used, circuits are going to be used to design this integrated circuit, which can be classified into three types. If you want to perform a analog operation or linear operation, like for an example amplifier, oscillators or etc., then we are going to be used this analog circuit design. When you are going to be perform a digital operation, digital performance, like for a system, the data storage, the data conversions, etc., will be performed by using this digital design operation. And the combination, analog and digital will be gives in mixed design. So in such a way that depends on our requirement, we are going to be followed the design process irrespective of your applications. If you want to perform analog, you have to use analog circuit design. If you want to perform a digital operation, you have to use a digital IC design process. So digital design, it is nothing but when you are used in a computer's memories like RAM, ROM, or processor, CPU, etc., where we are going to be used this type of method to design this RAMs, processors, or etc. What we are going to be perform ALU operation, CU, MU, etc. Any logical and arithmetical operation, controlling operation, data bit storage operation in memories, etc. Every operation in form of a bits only. So the bits operation can be performed by using the digital ICs. So when you are going to be design these digital ICs, you have to be follows digital IC design methods. So this method is circuit density maximum and overall efficiency also will becomes maximum. This gives that high output, high accurate output. And this ICs using method work within an operations of input will be 0 to 1 only, because our digital operations, the input and output will be in between with using zeros and ones only. If you observe this circuit, the process, how this digital design process will become look like. First, we are going to be consider our circuit, the requirement, what you have to, which circuit you have to perform, which logic you want to execute, which data you have to store, everything we are going to be consideration. And what is the requirement that we are going to consider in the system specification. Then the required input and output and all the specifications will be consist in a architectural design, what it should be required. Then we are going to be use those requirements. Based on that, we will design a functional block diagram, logical diagram, circuit design. We have to design a circuit to execute that operation, execute that logic operation. For an example, full adder or half adder or mux, demux, anything, any logical operation, combinational sequential circuit if you want to execute, it will be performed. So for that, we have to write a first consist a inputs and outputs. We have to, output is required, we have to analyze. Then we have to write a Boolean equation or etc. Logical operation expression we have to write. Then we have to design, irrespective of that expression, we have to design a circuit, logical block diagram. Then that logical circuit we have to implement into a circuit design by using the transistors or resistors. We have to be design this circuit. Then we have to send the physical design. What will happen in the physical design means it is going to be analyze your circuit. Analysis of circuit from input to output will be from block to block, pin to pin, circuit to circuit, logic to logic. We will be verified in this physical. And then the verification will be by doing this DRC means design rule check, and simulation and synthesis process will be takes place. Then after we will verify either it is give proper output or not, the logic is successfully executed or not, what errors we have seen, how we are going to rectify, how the logic is implementing. Everything will be analyzed with the various input levels. By giving the various inputs, we will analyze our expression. Has the given proper output or not for your design, physical design circuit. Then we will send to a fabrication. After final, that entire report will be in the netlist, which is called as a netlist. The report will be out. Based on this report, we will be analyzed our circuit, how we have to fabricate. So the fabrication people will be analyze this report to design your IC, the circuit designing. Then we are going to be design the circuit will be finally checked in proper given input and output, power supply, everything. Finally, that fabrication circuit will be released as a chip. That entire circuit will be dumped into a chip. This chip will be again retest to a physical test. Then we will release into a market in such a way that the process will be takes place. The design method will be follows these steps when you are going to be designing a chip. This process will be takes place. These are the most important common basic steps to design a IC. Analog IC, we know that analog the name itself it mentioned that That name itself mention that it is going to be perform an analog operation, like for an example amplification process or switching operation. It can be transistors will be actually switches, so we can be used a transistor to design an IC, then IC can be also used as a switch. So amplification process, oscillation, signal generation, or next to filter operation, voltage storage, analog frequency analysis, etc. Every operations can be performed. So for this performing operations, we need an IC. So we have to design our IC to execute this analog operations, which method is called as analog IC design. So the method which is going to be designed a IC to perform a analog operations like amplification, oscillations, filters, storages, etc. will be done. So such IC is called as analog integrated IC. So this design method is used when the power specification, power dissipation. So low power consumption, which will be gives high gain. The gain is defined as output response by input response. Output response by input response. So output voltage by input voltage will be gives the gain. So when your gain is high, so it will be gives high output, high voltage. So by that the strength of this circuit operation will be more, and the power will be very less, and high input impedance should be present, high resistance should be present in analog ICs. This should be perfectly, it has to be remember while using this design IC, analog IC. Mixed, it gives that combination analog and digital design principles. It has to perform analog operation as well as digital operation. For an example, we can use any DSP application, digital signal processing application. If you want to perform a digital operation, like when you have to give a input signal, then you have to go convert into a analog voltage. Sorry, when you are giving a digital input, it will be in from zeros and ones. By doing that ADC DAC conversion, any type method where can be used to convert digital pins into analog voltage. This voltage will be give some amplification, modulation, or any operation. Then that output amplification process. Then we are going some filtering operation. Again, that output is in form of voltage now. This voltage will be cannot be stored in any digital storage. So again, we will apply a ADC, which can be converted into a digital output. So digital outputs. This digital output can be stored any memory device, in such a way that we are going to be perform a mixed operations, like for an digital image processing or digital signal processing operation, where it can be runs with this type of mixed designs. Okay, and another examples of this one we can see this here: analog to digital converters, digital to analog converters, and clock timings. These are the examples where we will use mixed design, mixed level ICs. So for that, we have to be use the combination of analog and digital IC methods to design this mixed IC designs. And construction and packaging. Just now we have seen this in digital ICs method. You can see here the packaging and testing levels, the construction design, the fabrication process. These steps will be takes place in such a way that here, where you are going to be design this integrated circuit using some semiconductor electronic components, active and passive. So it will be included, it will be made up of active and passive semiconductor components, which are the silicon or germanium. And regular interval of time we will use maximum time silicon only, because the cut-in voltage of this silicon will becomes more compared to germanium. Germanium is a 0.3 only, 3 voltage cut-in voltage, but silicon is a 0.6 voltage or 7. Theoretically, it will become 0.7 voltage. So regularly we will use that as a silicon. Okay, and the integrated chip is a tiny, very thin or delicate, small weight, very less weight. We have seen the regularly that the large size of that devices is totally reduced into a small delicate size, very less weight. Handset size is also less, everything very. So we have to be handled. Hence, they are bonded into a set of tin and gold and aluminum wires are cast into the flat back of plastic or ceramic. Earlier, they have used that high weighted materials like aluminum, etc. Now we are going to be replaced into a plastic or ceramic material. We are going to be used to design this ICs. And the black has metal pins on the outside of the lids. So if you observe, for an example, if I see this, how this packaging or construction means, if you see this one, dual inline package, this black color is a plastic or ceramic. We are going to be, this is a ceramic or this is plastic. We are going to be used for the circuit, that integrated circuit block. But separately, the input and output pins are connected, designed or constructed by using this aluminum material, conducting material. Okay. So in such a way that we are going to be designed, by that we can able to reduce the weight of the IC. And the size almost is a very small size. Any much of the device also it going to be reduced into a palm or handset of size. Mobiles or laptop or what we will say that tabs, etc. It's totally reduced this size. So size of integrated chip is varies between 1 square mm to 20 mm. It very less size. And integration of IC is a combination of the multiple devices or components into a single chip. The huge circuit also can be dumped into a single chip. Thousands, lakhs of transistors we are going to be dumped into a single chip. It will be gives a very small size. A small size of IC. Memory card is one of the best example where it consists that thousands, lakhs of transistors will be dumped in. It can be stored 1 TB of data also. Presents coming out that memory cards or pen drives, etc. The microcontroller or microprocessor is another examples. Memory devices are another examples for this integration of ICs where that thousands or lakhs of components we are going to be dumped into the single IC chip. And logic gates, another examples commonly used in our laboratories. We have seen that we have executed that logical operations. We have seen this one. The combinational circuits we are going to be dumped into a single chip where the logic output based on the different input signal can be exist. Best example, this is that digital environment where we can use these ICs. And timer IC, it is going to be produced accurate response of your exit. The duty cycle is nothing but the response, how it is going to be takes place, how much time it going to be takes place to execute that operation. That is called as a duty cycle. So almost 100%, 50 to 100% of the output is going to be get within a high response, high accurate response with high gain also. And best another IC, the regular IC, operational amplifier. This is one of the most basic analog IC, integrated circuit. Op-amp, it's a short form of operational amplifier, which defined as a operational amplifier is a circuit, integrated circuit or integrated chip, which can be perform operations, various operations like adder, subtractor, amplification, modulation, filter, etc. There are multiple operations can be performed by using a single chip, which is called as a operational amplifier. And it consists a differential input. A differential input gives a single output. And with high gain amplifier. Now let me discuss this one. Operational amplifier. It is going to be perform a multiple operations like adder, subtractor, filter, converter. Next we will say that filters, converters, amplification process, etc. All the oscillator, signal generation, etc. can be performed by using a single chip with a high gain, high output voltage. High gain and high output voltage of differential input. Differential input means we are going to be consist two inputs. The difference between that input, it gives a output with a amplifier with a amplifier operation. And output the voltage regulator, also one of the IC, which will be gives a DC constant output voltage by the changing of DC input. The voltage regulator means it is going to be controlled your voltage with a static level or nothing but stable level with a constant level of changing output by the changing of input, but it will be gives a constant output when you are changing a DC inputs. The range it will be from the voltage regulator, the range is 0 to 30 volts maximum as the applications of integrated circuits. Now till now we have seen this the different type of ICs and analog or digital, any type of IC where we are going to be used. Best example, if I say electronic communication system, where the electronic is there also we need to use this integrated circuit. Where the communication system is there also we need to use this integrated circuits. So for an example, smartphones, MP3 player, laptop, computers. In MP3 player, audio signal, the amplification process, it can be use any ICs to amplify, and we are going to be use the laptop computer to store the data, to perform the digital operation, etc. It can be used the digital ICs where will be perform these operations, huge operations within the fraction of time with a high speed and accurate reliability output. And we are going to be used their television, cameras, etc. where we'll store that output and we can be record that output to watch after time period also. And for a long time we can able to store this by using this ICs. Only the one of the best application where we are seeing nowadays in the television, we can record our shows, our videos, etc. They are widely used in aircraft, spacecraft system. How means then in aircraft system where they are going to be a GPS monitoring system. We can say that it can be performed by using the ICs. For this we need an IC. We have to design the circuit to monitor the GPS system. That is also can be performed by using these ICs. And ICs are basic component as calculator, watches, digital watches we are going to be seeing nowadays, where we can see our sensors, physical sensed values also can be displayed in the screen. So these ICs will be stored that output, the data, the physical information and convert into that a system level where we can be display on your screen of the required values and watch, time period, etc. And they can be used in the control systems. The controlling operation can be performed by the feedback system where will be implemented accurate output to get that accurate output. Okay, so next topic is introduction to operational amplifier. So operational amplifier, what it means a basic definition. If you see this one, the basic definition is operational amplifier will looks like this. It's in a triangular shape where it consists 3-pin device, 3 main pins divided, where this dual inputs and single output operation. So what will happen means, if you analyze this one, when we are giving 2 inputs, the difference of the input will be gives as output, means output in form of voltage. Here we are going to be observed the output in form of voltage, where the 2 difference between the input, differential input, along with gain. So what is gain means? Gain can be calculated by using this output response by difference of your inputs, which is a V1 minus V2. So that gain is more, means here this operational amplifier can be perform a operation along with the gain, improving the output level. So amplification process also can be done. The multiple operations can be performed using a single chip is called as operational amplifier. The operations can be adder, subtractor, multiplication, then amplification, oscillation, signal generation, etc. can be performed by using a single chip, which is called as a operational amplifier. Is a direct coupled high gain amplifier. So we are going to be used at amplifier circuits to design this operational amplifier. We will discuss in coming classes. And it follows 2 inputs, along with gives a single output followed by a level translator output stage. So what are the blocks are consist internally means the blocks consist internally is differential amplifier circuit, then output another differential amplifier circuit, and then a level translator circuit, then output stage. Three basic blocks are going to be consist internally the level translator circuit, then output stage circuit, then we are going to get our output by giving some two inputs means here it is going to be perform a differential amplifier. Here differential amplifier circuit will be gives you a difference of input with some gain, and the level translator is going to be perform your adjustments, and then output stage will be improve your impedances, the DC level will be reduced, etc. We will discuss about individual each and every block with respect to the circuits, and we'll derive that, and finally we'll get that a maximum gain of output. So these are the three basic blocks are there to design a operational amplifier. What are those mean? Differential amplifier circuit and a level translator circuit and output stage circuit. So the pin diagram of your operational amplifier will becomes this one. One is a, here you can see 8 pin of IC. 8 pins will be look like, it will be look like a triangular shape, reverse triangular shape, and it basic 3 pins are. These are the 3 basic pins which can be perform your operation. These 2 and 3 are inputs, and output is your 6th pin. So second pin is actually reverse. Second pin is inverting, third pin is non-inverting, 6th pin is output purpose, and the 7th pin and 4th pin we are going to be gives a DC voltage which is called as VCC, plus VCC and minus VCC. This operational amplifier will be works under from 0 to 12 volts maximum. So we will give a VCC as a 12 volts plus VCC, minus VCC as a minus 12 volts, and the inverting pin, non-inverting pins as two inputs V1 and V2, where the output is will be displayed as V0, which can be V0 is equal to difference of your inputs. So with some product of gain value which is represented by AV, let us consider. So AV can be calculated by V0 by V1 minus V2. This is the way where we are going to be calculated our gain and output voltages using this operational amplifier. So how we have to design this circuit and what are the blocks are present, everything will be discussed in our next video. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.